there we go. Okay, so here we are. I think there's more people coming. Let's see who's signed on right now, if we have anyone on. We do. Okay, perfect. Then I'll start going. Yay, hi. I got a message that some people were running behind, but let's get started because I want to try to get this done. Let me just mute this tab. We do. Okay, perfect. Then I'll. Okay. So, yay, perfect. So this is going to be our final push for your test. You guys have spent 270 hours. Yay, people in class. And so now it's time for us to just make it count tomorrow. If you did not know, I think you can miss 6 questions and still do exceptionally well on the test with the conversion. Our goal, of course, is everybody proficient. That is our dream. What I've done today is I want to try to get us in and out in an hour. I can still hear Roblox playing. Let me turn off my Roblox game. Okay. So anyway, what we're going to do is we're going to go through, I pulled each of the DOK or the AKS that we've been working on, the academic knowledge and skills. And I'm just going to tell you what I could best guess of what it's going to be. I want to talk about probability first because there's 6 DOK 2-level questions on probability. There are 26 total questions on your test. So 6 of them are going to be on probability. So let's take a look here. The first AKS that you need to know is describing events as subsets using the terms of union, intersection, and complement. And what we've talked about before is we have this U here. I believe Brishane says that she makes this into an or. So it's A or B. Here's the catch. If it says or, you're going to have to use a formula sheet because the formula sheet says that if you do the probability of A or B, you're going to add the probabilities up and then subtract the overlap. So please use the formula sheet. And I'm going to erase all that so we can actually do some problems. If you have questions, please let me know because we will absolutely get to them. Again, I'm really confident you guys you've creamed the EOC. You'll be fine here. Intersection, though, that's where the 2 things overlap. That's what they have in common. So if it's a 2-way frequency table, the intersection is where they overlap. Be careful of the term given. Given, we're going to look at in another slide. That, of course, means the given is in the denominator. So let's take a look at this example here. We have a high school has 100 students, 80 play soccer, 70 play softball, 10 play neither. How many students play both soccer and softball? So this is my best guess of what a DOK2 is. Please use your paper. I think that's the only thing that'll mess you up is trying to do these questions in your head because of the 26 questions, 1 is a DOK1. All the other ones are DOK2s and 1 is a DOK3. So we know that there's 100 students. So I'm going to put 100 up here because there's 100 students in that total box. We know 10 of them do not play any sport. So that would be the complement. That's going to go out here. It's not going to be in either of the circles. We know that a total of 80 people play soccer. And we know a total of 70 people play softball. But we don't know how many the overlap is. So I'm going to put X in here for my overlap. So now, because the entire circle is 80, and I have this little X, this little piece here is going to be 80 minus X. This little piece here is going to be 70 minus X. And the reason why I'm doing minus X is because I'm getting a remind. So I just wanted to address that. Is because I don't know the overlap. Usually the ones I've given you, which are DOK1s, you know the overlap. But if you don't know the overlap, that's when this X and variable comes in play. So because there's 100 total people, we're going to just add up each of those 4 pieces. We're going to 1, 2, 3, 4. So we've got 80 minus X plus 70 minus X plus the extra 10 equals 100. So then I've got 80, let's combine like terms. So we've got 80 plus 70 is 150, plus 10 is 160 on this side. Then here we've got negative X plus X, negative X. So that's going to give me minus x equals 100 because these actually just cancel. So then I'm going to, you know what, I'm going to subtract 160 from both sides. That gives me negative x equals negative 60. And it's okay to have a negative x. I'm just going to divide that out by negative 1. So now I know that x equals 60. Again, this is my best guess of how they're going to take this standard and make it a DOK2. So now that I know that that middle section is 60 right here, what is my soccer going to be? What am I going to put down in that box? If I know the middle is 60, how much is left for people who just play soccer? Okay. There might be a little bit of a delay because I know it's 80 minus x. And because I just figured out that middle section was 60, I know that in total, why I wrote 80 minus x again, I don't know, is this one section here is going to be 20 people because that whole circle represents 80. 60 people play soccer and softball. 80 minus this 60 means there's 20 left on this side. Same thing over here. On this side, I've got 70 total people play softball. There's 60 who also play soccer. So I'm left with 10 here. So really, my picture would be like this. This is going to be 20. That's too small. So we've got our two circles. This part's going to be 20. This part is going to be the 60. This part's going to be my 10, and this part's going to be my 10. Now from there, I can answer questions. I know that 60 people total played, and I can say, what's the probability one person played or another? So a student is chosen randomly. What is the probability the student plays only soccer or only softball? Well, I know that there's 20 people who only play soccer. There's 10 people who only play softball. There is an overlap because the question stipulated that there was an overlap. There's two ways I could tell that there was an overlap. One way I could tell that there was an overlap is because if I add up 80 plus 70 plus 10, that gives me 160, and there's only 100 people altogether. So that's one way that I knew that there was an overlap. The issue is I didn't know how many people were in the overlap. So because I didn't know how many people there were in an overlap, that's why I put the X. And then I came up with each of the pieces being this circle is 80, 80 minus X is the little one piece. Then I was like, so 80 minus X was this piece here. Then I knew that 70 minus X would give me that piece and then my overlap. And that's how I did it. But I knew there was an overlap because when I added 80 and 70 and 10, I got a number greater than 100, which was the total number of people. So then I've got 20 plus 10. Oh, why did I put 30? That's what I did wrong. I got distracted looking at that message. So then when I add those up, I'm going to get 30, but there's 100 total people. So that means the probability would be 30 over 100, which you can reduce to 3/10 or 30%. So basically, the main thing I wanted to show you here, you got it. The main thing I wanted to show you here is I'm trying to think of how they can make them harder. So the one way I could think they make it harder is they don't tell you what the overlap is. Given that a player plays softball, so now that we know that a person has to play softball, we know that the denominator has to be softball because anytime you see given, you know that's the denominator. So we know that 70 total people played softball, so that's my denominator. What's the probability she plays both? So we know that there's 60 people who play both soccer and softball. And then you would get your answer that way. So it'd be 6/7, and I'm not going to use my thing to figure that out. Determine whether these events are independent. There's two ways to do independence. The main way that I've shown you is to look at the formula sheet. The formula sheet says that in order for something to be independent, the probability of A and B has to equal the probability of A times the probability of B. So the probability that A and B happen, we know, is 60 out of 100. And I'm not going to reduce the fraction because I'm just doing it to demonstrate. So then if it says, what's the probability of soccer? Well, how many people play soccer? There's 80 total people who play soccer. So that's going to be 80 over 100. How many people total play softball? 70. When I multiply that, I'd end up getting 56%. And 56 will not equal 60%, so they're not independent. Same thing for the softball. You're going to get those same fractions. But we'll talk about more independence coming up one more time in a bit. Okay, next. Here we've got mutually exclusive. There's supposed to be a 1 DOK2 question on mutually exclusive. We sometimes use the term independent. Mutually exclusive really is supposed to be or, that the two things aren't connected at all. We might also use the term independent. So although mathematically the formulas are different, they can be interchangeable when it comes to scenarios. So we've talked about something as independent or mutually exclusive if they are completely not related. So for example, rolling a dice and tossing a coin. The one dice is not going to impact the coin. Even rolling a dice 2 times. I think one of the questions on your strategies test was something along the lines of like, you roll the dice 60 times and 50 times you still get the number 5. What's the probability the next one's going to be a 5? You would think it'd be 50 out of 60, but nope, it's still 1 out of 6. That doesn't change. So buying toilet paper and steak doesn't make sense. Skiing while visiting Florida. And if you talk water skiing, that might be different, but that doesn't make sense. Reading a book and doing sit-ups. Those are mutually exclusive events. Flipping a card, flipping a coin, drawing a card. Those are not related. Also, anything with replacement. So you look at the red Skittle and you put it back. You still have the same number of Skittles. That is independent or mutually exclusive. Dependent deals with without replacing. Whatever happens depended on something else happening. You go to the store, you buy peanut butter and jelly. Makes sense that you'd probably buy peanut butter and jelly if you're craving a sandwich. You take your umbrella out because it's raining. You start eating healthy and you lose weight. Those things make sense. So that allows them to be dependent. If they make sense, if they relate to each other, they're dependent. Next. Here's another one with conditional probability. This whole idea of given. So given that something happens, given means it happened already. You know 100% it happened. So because you know 100% that happened, it goes in the denominator. So one of the sheets, I think it's the sheet maybe we got from Norcross, they gave you the formula, the probability of A given B. If it says, what if it says replace, then taken out again? Because it's replacement, it's still independent because you replaced it. So the formula is this. And the probability of B goes on the bottom. Whatever is last will always go on the bottom. So if they ask you, what's the probability of B given A? You know the numerator is always going to say the same. And the denominator is now going to be A. The other main thing to remember when it comes to conditional probabilities is you need to remember that your probability will always be less than 1. So if you have like 0.7 divided by 0.2, that doesn't make sense because your probability is going to be big. It's probably going to be like 2.5, 250%. You can't have 250% with probabilities. So that means you probably mixed up the order. You got to put the smaller over the larger one. Again, whatever comes after this line will always be your denominator. Next. Here, and then again, there's one other formula for given is if they say, is it independent? The other independent is the probability of A given B equals just the probability of A because it's 100% chance that B happened. I don't think you're going to see it, but that just randomly popped in my brain. So that's the other formula. Next, two-way frequency tables. I just copied and pasted this table online. There's no questions that go with it. So let's make some up. but it never said, okay, Jess, let's go back up and look. Do. Let's see if I can see the one that you're seeing. My drive. Do. I don't know if you're looking at the one on here, so let me just see if I have some questions we can look at. I think it's this one. Oh, okay. I was thinking you meant this one. Okay. So here, like letter B, we talked about in class, drawing a ball from an urn, not replacing it, and then drawing a second ball. So because it didn't replace it the first time, it becomes dependent. It doesn't matter if you replace the ball the second time because you're only drawing 2 balls. If you're drawing 3 balls, then again, it's the same idea. If you take a ball and put it back, take a ball, put it back, take a ball, put it back, as long as you put back every single one, it's still independent. But it doesn't matter if it says, but it never said the second one was replaced. It doesn't matter. As long as the first one was replaced and you're only drawing 2, it doesn't matter if it's replaced because you're looking at each probability separately. So like if we look at this one, we're going to do this question in a second. It'll help you. So let's go. Actually, let's jump there right now. So like, here we go. From a deck of 52 cards, 2 cards are being chosen without replacement. Yes, how funny. This is what we're doing right now. You read my mind. So let's look at this. So we have been playing cards in class for the sole purpose of you learning the deck. And the game that we play the most, I think period 3 calls it peanut butter, but it's BS. And the reason why we play the game is because I want you to learn the deck of cards. So this is kind of the saying that I wrote. There are 52 cards in a deck, 26 red and 26 black. This is how you can think of it. Each one of those cards could be a letter of the alphabet. There's 26 letters of the alphabet. So there's 26 red cards and there's 26 black cards. When you add that up, you get 52. So there's 52 cards in a deck, 26 red and 26 black. There are 4 suits in the deck. Of the red, the 2 reds are hearts and diamonds. And it makes sense. A heart, you think of a red heart. Diamonds, I guess, well, never mind. We won't talk about blood diamonds, but red, okay? The 2 black ones are spades and clubs. So in each of those, on top of that, each one, there's a number. The numbers start with ace. When we play BS, we put the ace first. That stands in essence for 1. So think of 1 through 10. Then you've got the jack, not the joker. The joker is 2 extra cards that we don't have to think about for math. The queen and the king. So let's look at this example here. It says, from a deck of cards, 2 cards are being chosen without replacement. So this goes back to what Jasmine was saying. Because it says without replacement, the total number of cards I'm picking from changes. Therefore, this would become dependent because I did not replace the first one. It doesn't matter if I replace the second one because I'm only picking 2 cards to begin with. It says, what will the probability be that the first one being black and the second one being red? So if I know there's 52 cards in the deck and it says 26 red, 26 black. So the first one is definitely going to be black. So I'm going to put a 26. And because it says the word and, I need to multiply. So now I'm going to multiply. But what happened is I picked one out. So now let's say I picked the 4 of spades. This black card doesn't exist anymore because I picked it out. I'm holding it in my hand and it says without replacement. So because I'm holding 1 card in my hand, that leaves me 51 cards left. Now, of those 51 cards, I started with 26 black, but I'm holding one of the black ones. So that means I'm left with 25. It's just like how third period when they play peanut butter BS, Once the person starts really winning, they start whispering, or not even whispering, to the other person, hey, who's got any more queens? Who's got the queens? Because they know if they have a queen and someone else has a queen, it changes the probability that the person who put down the queen as a BS is telling the truth or not. So that's why it changes. It matters when you know something. That's when dependence comes in. Now that we have that, we can just multiply across. And you would do 26 times 25 and 52 times 51. Hey, Google, what's 26 times 25? Hey, Google, increase the volume to 8. Hey, Google, what's 52 times 51?
The answer is 2,652.
There you go. There's your probabilities. So that's what it is. If it said with replacement, then I would go back to 26 over 52. This is with times 26 over 52 and go from there. So the main thing is, it's in this case, it's dependent because I'm holding a card. This case would be independent because I would put it back. And then when it's something's dependent, it changes your denominator and your numerator. All right, I'm going to move on and let's go back up here. Whoops. So if we have this table, let's take a look real quick again. If they say, what's the probability a person is male given they bought an SUV? What we're going to do is we're going to pay attention. Okay, this is on the back, so I know the total number of SUVs is going on the bottom. Here's my SUVs. 156 people go in my denominator. Of those 156 people, 21 of them are male, so that's what my answer is going to be. Yep, it did say 2 cards were chosen without replacement. I did both problems. Oh, but you know what I did wrong? Hold on. I think I did that problem wrong because it said black and red, right? I messed that problem up. I just made a mistake. I just realized it. Let me fix it real quick so I can tell you what I did wrong. So the issue is, what I did wrong is this was supposed to be 52 over 26. Holy moly. 26 over 52. I'm left with 51 cards in the deck. If I pull this 4 of spades, I stop paying attention. It wanted red. My fault. I will edit that part out later. I wanted red, so there's still 26 left. Hey, Google, what's 26 times 26?
The answer is 676.
Hey, Google, what's 52 times 51?
The answer is 2,652.
So when you pick one card and hold it, that is why you only subtract 1. Okay, now we're going to go back up. I am sorry, I completely zoned on that one. All right, let's go back to this one. So as I showed you that, again, if they say, what's the probability a person drives a sports car given they're female, then what I'm going to do is how many total people are female? 180. How many of those female drive sports cars? 45. Now, the other thing to think about for this table is you need to be able to pay attention to or. So if it says, what's the probability that a person is female or drives a sports car? Again, anytime we do or, you're going to use the formula sheet. So we're going to do the probability a person is female plus the probability a person drives a sports car minus the probability a person is female and drives a sports car. And remember, the denominator will always be the total. Anytime it asks you or, as long as there's not given, anytime they ask you or, that will always be the denominator. So I've got 180 total females. I've got 84 people who drive sports cars, and I'm going to subtract 45 because this 45 I counted twice. I counted it as female right here, and I counted it a second time for sports car. So because of that overlap, that's why I subtract it. 135. Hey, Google, what's 135 plus 84?
The answer is 219.
So then my answer will be 219 divided by 240. And then the decimal if you need that or not by doing the numerator divided by the denominator. Okay, I want to keep moving on. Let's go to the next one. Here's conditional probability again. I kind of already shared this on the other slide. Let's look at this example. The probability that it is Friday and that a student is absent is 0.03. Notice how it has Friday. Woo, that's awfully large. Friday and absent, 0.03. So that and is important because when it comes to independence and things like that, you're going to need to think about division. Since there are 5 days of school in a week, the probability that it is Friday is 0.2. 0.2. So what is the probability that a student is absent given that today is Friday? Again, we're going to do the probability of absent given Friday. Friday has to go in the denominator, 0.2. The numerator would be 0.03. Hey, Google, what's 0.03 divided by 0.2?
The answer is 0.015.
So that gives you 0.015. And then, of course, to go from decimal to percent, you multiply it by 100. So that would be 1.5%. Okay, I think that pretty much does it for probabilities. Let's just double check. It does. Yay, victory. Let's go on to circles. There are 8 questions on circles. This is going to be a little bit longer than an hour, but we'll be fine. The 8 questions on circles. One of them is a DOK1. That's our one DOK1. One is on DOK3. 6 of them are on DOK2. 2 DOK2s are on all circles are similar. So I was going to have you guys type it out, but I'm not going to because I want to move forward. I've been banging this in your head for so long. We know that all circles are similar. The reason that we know all circles are similar is because of the ratio of the diameter to the circumference. Remember that the formula for circumference is pi d. So because this pi is consistent no matter what, it's always multiplied by pi, that's why circles are similar. And so what we've talked about is, let's say we're going from B to D, 2 things have to happen. One is it has to dilate in any order. It can either translate or dilate. 1, there's a change in dilation for scale factor. And 2, there's a translation. So I typically look at the translations first. So if I notice here, my point is at -1, +5. That's where my center is. Now you could pick any point. You don't have to pick the center. I just pick the center because the whole shape's moving consistently because it's a rigid motion. For translations are rigid motion. So it preserves shape. 7, 4. So how did I go from B to D? Well, if I'm at -1, 5, and I got to 7, 4, what happened? Well, to get from -1 to +7, I had to add 8. And to get from +5 to 4, I had to subtract 1. So I know that I moved right 8, down 1. Or you might see x plus 8, y minus 1. Either one of these describe the translation. But translations deal with congruence. It doesn't deal with similarity. What deals with similarity is dilations. So remember, 2 things happen. Because the formula for circumference is pi d, we know that the ratio of the diameter to the circumference is the same because of that constant pi. So we've moved the circles. Now we need to shrink or get them larger. B is bigger, D is smaller. So I know my dilation scale factor is going to be less than 1. When I count here, I've got 1, 2, 3, 4 for my radius. Here I have 2 for my radius. The formula for scale factor is always new over old. So I've got 2 divided by 4, or a scale factor of 0.5. 0.5. So that's what happens. So that's how I did it for the circle. Now I'm going to do it again, but this time with if they give it to you using the equations. Remember, for equation of the circle, anytime we go from the equation to the center, we flip the signs. And also this value is squared, the radius squared. Because on the formula sheet, this is the formula that you're going to see for equation of a circle. So we have to remember to flip the signs and take the square root. So if I start for circle A, I'm at 2, -6, because -2 becomes +2, +6 becomes -6. I'm trying to get to B. B is -4, and there's no number here, so I'm going to put down 0. Now I have to think, how did I go from 1 to the next? Well, if I'm at +2, here's +2, how did I get to -4? I had to subtract 6. If I'm at -6, how did I get to +0? I had to add 6. So I know my translation is going to be x minus 6, which means left 6, and y plus 6, or up 6. Then I have to look at my scale factor. Here, my radius is 4. Here, my radius is 5. Because I'm going from A to B, B is my new, A is my old. So new over old gives me a scale factor of 1.25. So this one is a good example of what you could see for a DOK2 because it's testing 2 skills. It's testing, do you know how to find the equation of circles? Do you know how to find scale factors? Do you know all circles are similar? So here we go. Next. Okay, there is one DOK2 question, I believe, on this topic. The only thing I could think of it to make it a DOK2 is it had to be tricky. So these are the only tricks I could think about. Remember that when you have a diameter of a circle, a whole circle is 360 degrees, so a diameter cuts it in half. If you have an angle that has its endpoints on the diameter, that angle will always be 90 degrees because an inscribed angle, if it's on the circle, an inscribed angle, half of 180 will give you 90. The other thing is I was thinking is maybe they would do some kind of mathematical algebra with the opposite angles are supplementary. We know in a parallelogram, opposite angles are congruent, but here opposite angles are supplementary. So they might give you one angle and you have to find the other one. They might give you something like this, where you have an inscribed angle and a central angle sharing the same arc. In that case, we know that if this is 30, angle to arc, we multiply by 2. This has to be 60 because this arc is 60. This has to be 60. They might also give you something similar to what you saw in one of your strategies test, where the 2 angles share the same arc right here. So these 2 angles have to be the same. Down here, they might give you something dealing with segments. So you have a triangle. You probably remember seeing something like this, right? And then we were like, this is 5, this is 5, this is 8, this is 8. If they tell you this whole thing is 20, you would do 20 minus 5 to get 15 here and here. So something like that. Or something with the radius and the tangent forming a right angle, and you have to do some kind of stuff like with that. There could be more, but those are the best ones that I can best guesses for DOK2. Here's something here. There's one AKS on this. I think it's the DOK3. I don't remember covering this really honestly at all. So I apologize for that. It wasn't something that was focused on the EOC, I don't think, but let's just take a look at it real quick. There's 2 different things that deal with circles and triangles. One is an inscribed circle. An inscribed circle is inside a triangle. The way that you get the inscribed circle, is by doing angle bisectors. And so basically what happens is you have your circle or you have your triangle. And what you're going to do is you're going to bisect each angle. After you bisect each angle, that's going to give you this point, which is called, wait for it, in center. Does that make sense? It's inside the triangle and the circle, and it's in the center. After you find that, you're going to end up getting you're going to have to drop down to get a perpendicular. That perpendicular gives you the radius, which lets you draw the biggest possible circle inside of a triangle. There you go. Who knew? It was one of the AKS, so I just wanted to talk about it. The other thing that can happen is, how could you possibly get a circle? If you're given a triangle, how can you get a circle? Basically, what you do is, once you have your triangle, you have to draw your perpendicular bisectors, and that is what would help you to draw the entire circle. So here's an example. That the center of the circle is where the perpendicular bisectors meet. So if you're given a triangle, here we start with a triangle. We're going to draw the perpendicular bisectors, which I'm going to do my best guess. I don't even know if I can do a perpendicular bisector very easily of the line. So like this one would be like this one would be like maybe this way. This one would be like maybe here. So that would give you the center from there. And then from that, you'll be able to draw your circle touching everything. So who knows? I don't know if you need to know it for tomorrow, but when I was going through the AKS, I noticed that I did not do a good job of showing you that. The next AKS is 28. This is a DOK 2-level question. It talks about arc area. I have no idea what they're going to ask you. These are the only things I can think of. Don't forget, I just took this picture of a pizza from Pizza Hut. Arc length is the pizza crust. That's our arc length of it. Our area of a sector is all the good stuff. Okay, so arc length is the edge, area of the sector is on the inside. Remember, and you'll see it when you look at the formula sheet, but like this is the formula for arc length. And we've talked about how this right here is the formula for circumference. So all we're doing is we're taking the circumference, we're multiplying it by, it's a proportion. We're multiplying it by the angle we care about, theta, and then we're dividing it by 360 because there's 360 degrees in a triangle. This mentioned radian measure. I don't remember talking about it more than one time. And I think it was one of the accelerated questions that I showed you. This is basically radians. This is how I remember it, rad. So radians equals degrees and then pi over 180. So I don't know how you want to remember that. I don't know if it's going to be on there, but I noticed that it mentioned radian. So basically rad equals, so for example, if they say there's 2 radians, and they want to know how many degrees, and you probably see rads like if the calculator gets screwed up, all you're going to do is say, well, 2 equals, we don't know how many degrees, times pi over 180. So you literally are going to multiply everything by 180 to get rid of the denominator. If you don't get this, this is fine. It's only one question. Then you're left with 360 equals pi times x. Divide both sides by pi. And that's going to give you the degree measure. Hey, Google, what's 360 divided by 3.14?
The answer is approximately 114.65.
There you go. So that would be how many degrees it would be. I don't know if you're going to see anything like that, but if you do, that's what it is. Don't stress if you get it wrong. You've got lots of cushion. All right, next. Pythagorean. Okay, this one, I believe there's one DOK 2 question, maybe 2. There might be 2 on this. So let's talk about this. Remember that distance formula, Pythagorean theorem, and the circle formula are all literally the exact same thing that look differently. So we talked about, if I jump back over here, since I'm up here anyway, we talk about that picture I keep showing you of the circle. Where is it? There it is. Okay, basically, all we're talking about is how do we get from here to here? So we take whatever the x value is, we subtract this distance. So that's kind of how the Pythagorean theorem comes about. So what we're going to do here is group the x, leave a space, group the y, leave a space. So I'm going to go slowly for both of these because there is going to most likely be one question because it's on the AKS. So here I'm going to write x squared minus 2x, leave a space. Y squared minus 4y, leave a space. This has to come on this side because this is -4. I know this is going to be +4. Next, I'm going to use the formula sheet and write it out. To get down, I divide by 2. -2 divided by 2 is -1. To go up, I square it. Notice, if you square something, you will always put a positive number because a negative times a negative is positive. A positive times a positive is positive. Going down, divide. Going up, square it again. 4 plus 4 plus 1 is 9. From there, we can then determine things like the center is +1, +2 because we switch the signs. We can also take the square root of 9 to get the radius, which is 3. Let's say this is an ugly number. Let's say they tell you that it equals 27. I'm making this part up. Then your radius would just be the square root of 27. No big deal. If they give you like the square root of 17, don't forget when you square it, it's just going to be plain 17. Remember, that was something that you guys got stuck on the interim. Looking at another one here again, x squared minus 16x plus y squared plus 8y. There's nothing to move over. Oops, I forgot to leave my spaces. So I'm just going to leave it. Here I've got x minus 8 squared. 8 times 8 is 64. So I'll put a 64 here and a 64 here. Half of 8 is 4. So this is y plus 4. 4 squared is 16. Add these up. 180. So then again, +8, -4 is my center, and the square root of 80 is my radius. We're getting their volume. There are 3 DOK2 questions on volume. I'm betting one of them is going to be on Cavalier's principle, which is right here. Use Cavalier's principle to decide which of the figures described below have the same volume as an oblique cone with a base of 3 and a height of 12. So basically, we're going to, all we care about is the base. Remember, the cross sections have to be the same. Now, because this says cone, we do have to think a little bit more in the sense of the formula for cone is 1/3 pi r squared height. The formula for a cylinder is pi r squared height. So we know it's not going to be choice A because a cylinder and a cone don't both all taper to the top. So it can't be that. Now, it could have been a cylinder and a rectangular prism, but it won't be a cylinder and a cone because a cone goes to a point. Here, this says a right cone, so that's possible. This says a pyramid, so that's possible. This is a rectangular prism. A rectangular prism doesn't come to a point, so we're not going to test that. The formula for a cone is, again, 1/3 pi r squared height. So if we plug this information in, we get the volume equals 1/3 times pi. The radius is 3. The height is 12. Here, if we plug that stuff in, so if we simplify this 4/9, this would become 36 pi. If I do this here, this is going to give me 1/3 times pi with a radius of 6 squared and a height of 6. So if I simplify this, this is going to give me 72 pi. So I know that that's not the same. So it's got to be choice C. And then a pyramid, remember the formula for a pyramid is 1/3 base, big base times height. They tell you the big base is 9. So then you can plug that in and that's how we get it. Because if we do 1/3 times 9 pi times 12, well, when we multiply this in the calculator, that gives us our 36 pi, which is what we got from the beginning right here. So that's why it's choice C. We're getting there. We're getting there. Okay, a couple more. I'm just going to do these a little bit quickly because most of you saw them already. A circular garden has a diameter of 12 feet. Remember, if you see diameter, you're going to need to make sure you change it to the radius. How many topsoil could Linda buy to cover the garden if it covers an area of 3 square feet? So basically, you're going to have to find the area of the garden, use the formula sheet. They give you the formula. Once you get that number, then you would divide that by 3, and that'll give you your answer. Here for cube, they don't give you the volume of a cube. You have to remember base times width times height or sides cubed. Remember that this is just exponent rules. Pardon me, when we cube or square something, that's the same thing as saying 7x times 7x times 7x. So then we have to multiply all these together, and that gives us our 343x cubed. I expect there is one question on cross-section. I expect it's going to be a not question. And so we'll look at some cross-section examples, but that means you're going to see which ones are correct and then see which ones are not correct. They might also give you something like this, where they haven't solved it. They've just plugged things in, and you have to look at the formula sheet. Again, I'm trying to think of ways, how can they take it from a DOK1 to a DOK2? This makes it look more complicated. So that makes it a DOK2. The other thing to remember is it mentions the word diameter. That also makes it a little bit more challenging. Anytime they say altitude, that's just a fancy word for height. Next. Here are pictures. There's one picture on cross-section. I apologize. There's one question on cross-section. Remember, you can only ever get cross-sections that are equal to or less than the number of sides. So for example, here is a circle. You can get a circle, you can get an oval, or you can get a rectangle. Here you can get a triangle, you can get a square, and I've also shown you how you can get a trapezoid. Here, this will always be a circle. The cross-section of a sphere is always a circle. Next, doubt you'll see a cross-section of a cone. There's a parabola, a circle, an ellipse. I don't think you'll see those, but then of course a triangle. Remember, if you go vertical is going straight up and down. That's vertical. That's also perpendicular. Parallel goes across. Everything is relative to the ground. So this is parallel, goes across. It's also horizontal, like the horizon. Brichonnet remembers it that you always stand perpendicular to the ground. So that's how she remembers it. For this shape, remember, this is something I had to look up because I had no idea that a pentagon could be inside of a cube. You can get a rectangle by doing the diagonals. You can do a triangle by doing the sides. The trapezoid is you cut some of the top, some of the bottom. The pentagon is like you cut 2 corners out somehow. I had to look it up. That's what it is. And then a hexagon, which is a 6-sided figure, and a cube has 6 faces. You can get in by adjoining the midpoints on 6 of the sides. So the biggest thing you could get is that I'm getting distracted by a squirrel that just decides to sit on my chair outside. I apologize. Coordinate geometry, there's 5 DOKs. There is one DOK, or there's one question that relates to proving theorems. I'm not going to go over these. You should know these already. If you need to go back and pause it, you can. Yeah, I'm not going to go over it. Just remember, slope formula is rise over run. You would use slope formula to do opposite sides are parallel for a parallelogram, or you would do slope formula for adjacent sides are perpendicular, as that you need a right angle for. Or you can even do slope formula for perpendicular diagonals, like in a rhombus or a square. I'm not going to spend time on that. This one, there's 1 or 2 questions. I think there's 2 questions on proving the slope criteria of a parallelogram. Sugar shoots of parallel perpendicular lines. So I'm going to show you one with parallel, one with perpendicular. I've always shown you find the slope first. Let's do this one as parallel and this one as perpendicular. So we have our slope first. Second, we're going to plug. We need our parallel slope. So our parallel slope is going to be, except I drove blah, blah, blah. Slope is 3. This is parallel. This is perpendicular. Our parallel slope is 3. Then we're going to plug this in for x and y. So I've got 7 equals 3 times my parallel slope plus b, because I'm trying to solve b for slope-intercept form. This gives me 7 equals 6 plus b. Subtract 6 from both sides. And then now I do my final substitution. Y equals my parallel slope, 3, plus my b that I discovered, 1. For perpendicular, here I've got my perpendicular slope. If my regular slope is 1/2, I know my perpendicular slope is the opposite reciprocal. So this is positive, so this will be negative, and then I flip the fraction. Still do my y equals mx plus b. Plug in the values. -5 equals -8 plus b. Add 8 to both sides. X equals 4, not 3. Ooh, good catch. 4, 12, 5, 5. Thank you. And I was looking at that twice and I couldn't really figure out why. So that's actually going to be -5. Good catch. Thank you. Here, add 8 to both sides. This becomes +3. So I'm left with y equals my new slope, which is -2 plus 3. Now I'm double checking my work to make sure I did it correctly. Yeah, I'm confident with that. Good catch. Thank you very much. Next. So 2 questions on that, parallel, perpendicular. 1 question, DOK 2 on directed line segment. Please get this right. I promise you I will cry if you don't. The only thing I can think that they can make it more challenging is they don't tell you the ratio is 2 to 3. They say something like it's 2/5 of the distance. So if they say something like it's 2/5 of the distance and not in a ratio of 2 to 3, don't forget to kind of draw the line. This is your A, your B is going to be 5 minus your A. So 5 minus 2 gives you the 3. Let's solve this with the ratio of 2 to 3. I always teach you to do the x first. So we've got bx1 plus ax2 over b plus a. So my b is 3. My x1 is always on the left. So this will be my a, or my x1, y1. This will be my x2, y2. So I've got 3 times -7. A is 2. X2 is +7. And when I add those up, I'm going to divide it by 5. Then I remember I always write it on top. So I've got -21, 14. That's going to give me -7/5 for my x. And then my y. So I've got 3 again. This time I'm going to use my first y. 2 again, using my second y. All over 5. -18. +14 gives me -4/5. So it's going to be -7/5, -4/5, about right there would be my point. It's okay if you're going to get fractions and decimals. I expect you probably will, only because it's a DOK 2, unless they decide to be generous, which they might, but I'm not so sure. Next. There is supposed to be 1 question on computing perpendicular perimeters. Excuse me, please use your graph paper, make your life easy. I don't know why I picked this because this person numbered it horribly, but let's look at it anyway. -3, 0. That's A. Oh, except, wake up. -3, 0, that's A. +3, +2 is B. +4, -1 is C. And -2, -3 is D. Connect the dots. Now, the reason why I want you to graph it is unless you are exceptional at distance formula, which you definitely have to use distance because it says perimeter, just use Pythag. So we're going from here to here. So I've got 2 and 6. So I've got 2 squared plus 6 squared gives me 4 plus 36, which gives me the square root of 40, because remember, you always take c squared, you got to take the square root. So I know that this is going to be the square root of 40. And because it's a rectangle, this has to be the square root of 40. Here I've got 1, and here I've got 3. So I've got 1 squared plus 3 squared. That's going to give me 1 plus 9, or 10. And then because they know that, I can do this, and then you can plug it into the calculator. Don't forget for area, you're going to multiply. The top of the formula sheet, it tells you perimeter of a polygon is to add all the sides, and then area will tell you that base times height, or length times width. You guys are doing great. Almost done, almost done. 3 more questions. We're on it, we're on it. Okay. There are 3 questions, 3 DOK questions on 3 DOK2 questions on here. I'm going to go through a couple of them real quick as ideas. Anytime you see density, don't forget that the word per means division. So per something is you're dividing. Now, I didn't see the test. You guys are the ones asking me after you took the pre-test, how do you convert? So I pulled something up to show you a couple things. Remember that the numerator when you do density is always going to be things that you can count or touch, for lack of a better description. The denominator is always going to be something like space or area or volume. So here we've got a plane, and then you would sometimes cross multiply depending, which is what this is. So we've got a rectangular block of copper metal weighs, you can measure that. So it weighs 1896. Here it tells the dimensions and it wants to know the density. Hey Google, what's 8.4 times 5.5 times 4.6?
The answer is 212.52.
Hey Google, what's 1,896 divided by 212.52?
The answer is approximately 8.922.
There you go. Thank you, Google. So then that's going to be grams per centimeter squared. Cubed. Down here, we're comparing Elena, who can build 8 computers in 13 hours. In and per, again, stand for division. Sage can build 10 computers in 16 hours. Who can build it faster? Well, if we've got Alana here, she can do 8 computers in 13 hours. Hey, Google, what's 8 divided by 13?
The answer is approximately 0.615.
Okay, so that means she can build 0.615 computers an hour. We have Sage. Hey, Google, what's 10 divided by 16?
The answer is 0.625.
And Sage can build 0.625. This is bigger, so Sage builds the computers faster. So density isn't always like that. You know, it could be other pieces. Now, I do want to talk about this. This center is our unit of measure. Anytime you go, this is actually some Spanish thing I found on one of the sites. Anytime you get bigger, you're always going to multiply. The only things I can think of them probably doing is the middle. So like this is like milliliters. This would be kiloliters, which we never use. So I doubt that. Oh, that wouldn't be milliliters. That would just be plain liters. And then milliliters would be down here. So if we're going from milliliters to liters, we're multiplying by 1,000. If we're going from liters to kiloliters, we're multiplying by 1,000. You're almost always multiplying by 1,000. The only time you're not is if you're going and if you're getting better, going like from centimeters to meters. Or you might have grams. You might have the unit be grams, and then you might have milligrams, and you might have kilograms. Again, usually speaking, unless it's centimeters, you're going to be multiplying by 1,000 to get bigger or dividing by 1,000 to get smaller. So here, milligrams to grams, I'm multiplying by 1,000. Grams to kilograms, I'm multiplying by 1,000. If I'm going from kilograms, oh, wait, did I just say that right? I think I just totally screwed us up. I did. Holy moly. Don't listen to me. I was looking at the time and I just stopped using my brain. I was wrong. I'm wrong. That's not what we do. We multiply going this way. If we're at kilograms and we're going to grams, we're going to multiply going down. and we're dividing going up. I'm so sorry. I said that wrong. So what does that mean? Let's say they tell you that you have 7,000 kilograms and they want to know how many grams do you have. You're going to take your 7,000, multiply that by 1,000, and that's going to give you your total number of grams, which is 7 million grams. If they told you that they had 7,000 grams and they want to know how many kilograms you have, we're going to get smaller. So we're going to take the 7,000 divided by 1,000, and 7,000 grams is going to equal just 7 kilograms. So whenever you get bigger, you're actually dividing because the number gets smaller. Whenever you get smaller, you're actually multiplying because the number has to get bigger. I can't believe I inverted that. I apologize. Okay. If you were completely confused, Google metric conversions and then watch a video and it'll make a whole lot more sense when we're done. But let's go through their last couple problems and then we're done for the night. Metric conversions. That's what you want to Google if I completely confused you. Next, here we go. Wafer cones to hold frozen yogurt have a radius. This obviously must be from another country because of how they spelled yogurt. Has a radius of 4 and a height of 7.2. What is the volume of these cones to the nearest milliliter? So because it's a cone, we know we're going to use 1/3 pi r squared height. So that gives me 1/3 times 3.14 times the radius squared times my height. This one I'm not going to ask Google for. Calculator. 3.14 times 4 times 4 times 7.2 equals divided by 3 equals. So this will give us about 120.576. Then, and that's how many milliliters. Ooh. Why would they have centimeters to milliliters? This conversion, I don't know what they're doing. So let's just leave it like that. Then they tell us it's 40 liters. Well, in order for us to convert from milliliters to liters, you have to, again, we talked about anytime you're going from a smaller to bigger, you're dividing. So this is going to be divided by 1,000. So that means that each cone can hold 0.12, and I'm not going to, we'll say 1. It can hold 0.12 liters because if I go from milliliters to liters, I know I have to divide by 1,000. 1,000 is the key number. The only time it's not the key number is when we're dealing with centimeters, but I'm not sure. I must have not copied everything over to get that conversion. So here, if they tell you 40 liters, you're going to then do 40 divided by the 0.121, and that's going to give you that you can get 330 total ice cream cones out. So let me say that again, because I think I didn't copy the whole question down. Sometimes, I think the question I showed you earlier was the one with the circular garden and putting dirt down. So sometimes you have to find out one piece of information. In this case, first we had to figure out what was the volume of the cone. Then from the volume of the cone, we had to take the total number of liters and divide that out to find out how many cones we could get. In the circle problem up here with the garden, where is it? This one. Here, it was the same idea. In theory, first we would have had to figure out what's the area of the circle, and then from there, divide out to see how much we can cover and how many bags we need. So my point is sometimes you have to do 2 steps for one question. That's what we're doing for the DOKs. Let's look at this last one. A soccer field is a rectangle, and then we're done. A soccer field is a rectangle that is, unless you have questions. So if you have questions, start typing them now so I can see it when I'm done with this question. A soccer field has a rectangle that's 90 by 120. The coach asks the players to run the longest distance. So anytime you have a rectangle, the longest distance is always going to be the diagonal. always, because it's the hypotenuse. Remember, a rectangle has a right angle, so that means it's a right triangle. So the longest side or the longest distance is always going to be diagonal. So then how do we get this one? All you're going to do is a squared plus b squared equals c squared. Oops. The only other thing I just realized that we didn't talk about, oh no, I was right, is we didn't talk about trig, because I remember someone telling me trig was on there. So I can do that real quick if we need to. This will become 8100. Yep. Plus. I'm doubting myself. Nope, I shouldn't be doubting myself. Oh, that's what I missed. That's why it didn't look right. Plus 8100. And then we take the square root. And when you take the square root, you get 150. So that's pretty much what I had for us to go over. Don't forget, for sine, cosine, and tangent, theta is always the angle you're talking about. The hypotenuse is always opposite the right angle. When you go across, that's your opposite. And your adjacent always touches the angle. All right, that is all I can think about for you. This is my little meme I found for you. Chill, you got this. Really just take your time. Please use as much of the time as you can. You're going to be given a total of 90 minutes. So we'll do a quick 10-minute review, get ourselves settled, and then take the test. I should have the results by Tuesday. So on Tuesday, you should know your overall grade. All right, that's about it. Thanks for staying the extra 7 minutes. I will catch you guys later. Let me say thank you for coming. Just to make sure we got everything. Okay, great. Great. All right, I'll see you guys later then, because it doesn't look like I have any questions. So if you do have questions, you can just send me a reminder at eRig, and I will get back to you. All right, thank you so much for watching on a Sunday. You guys are awesome.